Hi, my name is Yong-Bee Lim. I am a doctoral candidate at George Mason University, and I'm also a Baltimore Underground Science Space Community Lab member. And I am super thrilled to be here to give you this talk. I think that it's fairly apparent when you look at the title, what I'm going to talk about, and that's about the dangers of assumptions. So let's get on with this talk about you know what they say when you assume. So as a brief background about who I am, just from a professional vantage point, I'm clearly a guy that's into some style. I love glasses and I love wooden bow ties. I've been involved in national security and looking into it for about the past decade. Also, I am involved in community labs and community organizations. So I've been very fortunate the past few years to be involved with the Global Bio Summit. Just so you know, Global Bio Summit 4.0 is coming up, biosummit.org. So go check it out and register while you still can. And like I mentioned previously, I am a doctoral candidate at George Mason University looking at DIYBio. So the thing that I also wanted to point out, because everybody is a multifaceted individual, is I wanted to see what the internet would pull up when I decided to talk about things that are personal about me. So interestingly enough, these are the images that came up, and the first one to the upper right should be pretty obvious. It's me hanging out with a friend of mine, Natalie Ma. This is actually at Santoka Ramen in Boston. So I'm a huge fan of ramen. In the bottom right-hand corner, it shows me being involved in a community lab project called Barcoding the Inner Harbor, along with other members such as Syra, and also actually the founder of Bugs, Tom Burkett, in the photo in the lower right there. In the lower left-hand corner, you can see that I think of myself, I guess, as a flamingo. I just thought this was a really fun picture because this photo was taken when I was traveling in Seoul, South Korea. I'm a person that really loves to travel. And interestingly enough, this focaccia bread picture popped up in the internet search. And so it seems to show that I have a real appreciation for baking and for carbohydrates, which shouldn't be terribly surprising given the ramen photo. So, that's a bit more about me, apparently, according to the internet. So I really want to now get into the meat of this particular talk, which deals with this idea of assuming. So you know what they say when you assume, and I think that Moira Rose does a fantastic job in this animated GIF of explaining that. Never assume, dear, it makes an ass out of both of us. So what do assumptions have to do with kind of my talk and my life story here? Well, to get to that, we need to start with an origin story. So I'd like you to picture it, a la Sofia Petrollo. It's at George Mason University in 2015. That's when The Force Awakens came out. I just really like that animated GIF, so I decided to put that in there. So when I was a PhD student at George Mason University in 2015, that's where I had my first exposure to these concepts of do-it-yourself biology, community labs, people doing the life sciences outside of conventional, traditional areas like academia, industry, and government. And this was my first exposure to it. So if you look through any of these particular images, you can see that the image presented of do-it-yourself biology, community labs, amateur science is a pretty horrifying one. There's this idea that amateurs could create mutant viruses. There's this idea that these people are actually creating biosecurity issues. There's an idea that non-state actors could use these technologies that people are using in unconventional ways to exploit synthetic biology for terrorist purposes. And as more people engage in these types of activities, it's possible that, according to this 2018 New York Times article, that people will get hurt as they continue to do these DIY gene editing experiments. So my first impression of do-it-yourself biology and community labs is not terribly surprising. I think Archer explains it best here with "Welcome to the danger zone," because it certainly feels like a danger zone type situation. It feels very dangerous. It's about people that I don't understand. And that's the impression that I initially had. So clearly, I'm speaking to you here right now from the comfort of my own home during this virtual conference, and I've clearly had a change of heart. And how did that change of heart happen? Well, I think that there are three precipitating reasons. The first is I'm a home brewer. Starting in 2012, I go visit Korea. I try to visit once, sometimes twice a year. And I really got into home brewing. They have a rice wine there called makgeolli. And if you listen to my interview podcast episode with Nina and Bo on white hats and lab coats, I talk about a little bit about my home brewing experience. But I kind of came to realize, and I used this book, I realized that sake is Japanese, makgeolli is Korean, but I kind of came to realize that home brewing in itself is a form of, doing biology outside of conventional spaces. And so, that kind of got me open to this idea that maybe biology in unconventional spaces is not only something that's desirable, but it can be something that's delicious. So the second thing that kind of got me thinking about how biology in unconventional spaces could be a good thing was this idea that I was talking about myself as this kind of emerging tech, biosecurity expert, but the more that I got into the biology of it all, the more that I realized that biology is actually really hard. I kept having to go back through basic biology textbooks to just get a basic understanding of a lot of these very complex ideas and complex technologies that were coming down the pike that I was supposed to be able to understand. So I wasn't sure at one point if it was that biology is hard or that I'm just a horrible student. But I eventually realized that having community lab spaces as a place where people could learn biology at their own pace would actually be helpful to me from a professional and educational standpoint. And finally, the third thing that changed was I was very fortunate to get a research assistantship in California at Lawrence Livermore National Lab. And I met this gentleman in the upper right-hand corner, Patrick Desailliers. He is a founder of one of the first few community labs in the United States, Counterculture Labs in Oakland, California. And he learned it through the grapevine at Lawrence Livermore National Lab that I was interested in do-it-yourself biology. And he, at one point, came up to me and he asked me, hey, so I hear that you're interested in community labs. And I said, yes. And then he asked me, have you ever been to a community lab? And I said, no. And so he offered me literally a life-changing opportunity with an invitation very akin to Arnold Schwarzenegger in the lower right-hand corner. Come with me if you want to live, or at least come with me if you want to learn more about community labs. So actually getting that initial introduction, actually getting that invitation to come and participate and observe was a really eye-opening experience for me in 2016. And over the past 5 years, I think that it's really developed a number of changes in the way that I think about community labs and DIYBio that are very much with me to this day. So I know some of the people in the audience at this point are saying, origin stories are great, but if you could get to the point, that would be great. So here's the point. This is often the situation, there's a major problem when we assume things. So as much as we like to think that we know everything under the sun, that is not a true fact. That is fiction. There are the known knowns that we know of, but if we're not willing to push ourselves beyond the known knowns into the other areas, particularly in my case, in regards to DIYBio, the known unknowns. So, we know that there are like particular issues that may be existent, but we don't necessarily understand what this phenomenon is that we're observing in the first place. Unless we're willing to push ourselves to expand our idea of the known knowns, we often work off of assumptions. And once again, TLDR, remember what Moira says, it makes an ass out of both of us. So I just, as the start to this whole entire talk, I wanted to get people to think about this idea of assumptions and understanding that assumptions aren't facts, assumptions aren't truth. What we need to do as responsible citizens and responsible scientists is to, when we run into a particular situation that we don't know very much about, have the willingness to be curious and open-minded and go into that new area, this kind of like, this strange new world with, an open mind, and be willing to kind of process information as we go along and allow that information to help inform us as we, expand our knowledge and arrive at particular conclusions and policy recommendations. So we are finally here now. My talk is on understanding the do-it-yourself biology and community labs scene. And it is a bit unusual, I think, in the biohacking village context, because a lot of you people are like incredibly technical people, and I would not be able to do half the things, actually even a quarter of the things that the people do in this audience on a regular basis. So, testing vulnerabilities and various types of software, imagining, all of these kind of like red teaming, like cybersecurity type events. That's amazing. It is amazing that you can do it. I really hope that you find this to be an interesting talk, because social science, I think, is often referred to as a soft science and sometimes kind of pushed to the side. But I think there's real insights here that could be helpful, not only from a policy standpoint, but from a community standpoint. So I'm going to go forward with that kind of perspective in mind. So here we are, finally at the main event. No crazy animated GIF here. I just wanted to go over a few basic facts about the do-it-yourself biology community from my research. So there aren't very many reports about the do-it-yourself biology community. One of the main ones was from 2013, authored by Dan Grushkin, Todd Quicken, and Piers Millett. So in terms of its history, it appeared to emerge somewhere in the United States from about 2005 to 2008. It's now a global phenomenon with community labs popping up all around the world. A lot of people associated with the do-it-yourself biology movement in the early days include Rob Carlson, who built his own biolab in 2005, and he talked about, in a Wired article, how people could maybe start doing their own community lab work and learning community lab skills from the comfort of their own home. And then Jason Bobe and Matt Cowell in 2008, they were based in Cambridge, Massachusetts, and they had this idea of making biology more accessible and easier to do, particularly from the angle of synthetic biology. So having people, providing people with the knowledge and the tools to be able to engage in biology and do some really fun and cool things, from the comfort of their own home or from community lab settings. So the 2013 report discusses how this community started as a small online forum. It was an online Google group called DIYBio. Current estimates estimated at 3,000 to 4,000 individuals associated with the movement. It's highly decentralized, consisting of actors ranging from individuals to regional communities. The individuals from that 2013 report, they noted that people tended to be more educated and younger than the general population. And these community labs and these kind of garage labs tend to be centered in highly developed urban locations with higher education academic institutions. So in terms of DIYBio, in terms of its values and goals, it's very much about democratizing technology. And when we talk about democratizing technology, I see it as 4 separate but interrelated concepts. So there's increasing access to technology, increasing access to knowledge, so the internet, but also increasing access between people to have conversations, to talk about science. distributing scientific practices to a broader community and distributing capability for a broader community. So broader in terms of the number of individuals and broader in terms of ways of usage. So I think that it's very much the idea of DIYBio that people see the democratization of science as good news, as Professor Farnsworth clearly acknowledges, and this idea that not only do academics and industrialists and government have science, but we as citizens have science and should have access to science and should be able to do science. So in terms of my research, what I found in terms of DIYBio activities were they encompass 4 general categories. So the first is exploration. People in the DIYBio community like to explore, everything from within themselves to their local and regional environments. So that's, a vehicle that DIYBio uses to enable people to explore their surroundings. He-Man, clearly with the I have the power, indicates that DIYBio also really believes in empowering individuals to be able to engage in biology and to be able to leverage biology for their own particular sets of purposes. In terms of another activity that DIYBio does, there's a lot of education that happens in do-it-yourself biology contexts. So there are lectures, there are hands-on lab skills classes, there are casual conversations where people just talk about various topics, and before you know it, they've talked about this entire area of science that they're really excited about and really excited to collaborate on. And finally, there's an entrepreneurial element. So there are a number of community labs that function as early stage incubators for small groups and individuals to come in and maybe develop a proof of concept or get some data that hopefully they can then use to develop a product, and very much in the style of Fry there, have people tell them to shut up and take their money. So question here is, how do national security professionals and practitioners typically feel about what I described? If you remember back maybe about 15 minutes ago, surprise, we're back to the danger zone again. There's this real concern that as people have access to these technologies, that they can do all sorts of things with them, and they're not necessarily benign things that people can do. So scouring through the WMD literature, especially as it relates to non-state actors, but the WMD context, I noticed 3 general trends or 3 general considerations that national security experts seem to be focused on when they think about the change in risk associated with the development of WMD and the use of WMD in the modern day. So in terms of capability, as capabilities increase, as people can do more things with the technology, that means that people are then able to leverage that technology to do lots of things. So if people are able to do lots of things, that increases the playing field of not only could they use the increased capabilities for good, but also for nefarious purposes. The second major trend that I noticed in terms of assessing WMD risk is increases in convergence. So there are lots of different players that are getting involved in science nowadays. And it's not just, citizen scientists, but disciplines are also converging. So synthetic biology is actually a convergence between biology, the traditional life sciences, and the application of engineering principles to biology, trying to make it easier to design, easier to test, easier to build, making it easier to produce products with. So as these different groups and different communities engage with each other, there's less certainty about what the outcomes will be. And it's harder to predict what outcomes will come from what interactions. And so the lack of certainty also contributes to this sense of concern that as more communities work together with each other, or different disciplines work with each other, you're going to end up with this, you're not sure where, what's going to come out of those interactions. And finally, in terms of increased accessibility, technologies, people talk often about how gene sequencing and gene synthesis prices are consistently falling rapidly. So that makes them financially more accessible to a broader audience. Technologies also are becoming more available secondhand on secondhand markets, because there are a fair number of biotech companies that, there's a high rate of failure in biotech. So when a company goes out of business, they often set things up so that they either donate their equipment to other people that, are interested in them. They sell them on eBay. So as these technologies become more accessible to a broader audience, there's also this perception that there's a loss of control of the equipment, of the reagents, of all of these things, which then contributes to this idea that the risk of weapons of mass destruction, development, research, and use are increasing. And these are just some examples from the state actor perspective. So in the upper left-hand corner, you have a 3D printer. One of the concerns with 3D printing is, as it becomes more capable, as we're able to do more granular things with it, maybe states or potentially non-state actors could use that granularity, that specificity, to develop nuclear weapons parts or parts for a nuclear centrifuge. In the upper right-hand corner, we have a graphical image of CRISPR. So this idea of gene editing. And as gene editing becomes more prevalent, as gene editing becomes more accessible to a broader audience, it becomes not only harder to control the technology, but it also is just really hard for people to arrive at what would be approved and unapproved uses of gene editing technologies. Because as you broaden the pool, you have an expansion of opinions. Opinions are like assholes. Everybody has one. And so, it becomes harder to arrive at a consensus when it comes to technologies that become increasingly accessible. And then, within the non-state actor context, here's that concern again about the use of weapons of mass destruction or the facilitation of uses of weapons of mass destruction. So as drone technology becomes more prevalent, it may be possible to use drone technologies themselves as a weapon of mass destruction, in terms of, if you have a concentrated number that's swarming, attacking a particular position, that could result in massive casualties and massive damage. We're looking at the fact that drones with swarming technologies may aggregate and be able to be used by non-state actors to do significant damage to infrastructure, to individuals, things along those lines. To the upper right hand, that image, in terms of the non-state actor space, that was a sarin factory in Japan that was being run by a group called Shinrikyo. The bottom image is in reference to Amerithrax, a domestic event that happened in 2001, largely believed to have been done by a single individual through the distribution of anthrax to the postal system. So with this, with these three kind of considerations in mind, these three relationships of what is driving risk, WMD risk related to the life sciences, where does do-it-yourself biology fit? And I would argue that if you look through the lens of a national security person looking through this framework, that you could argue that do-it-yourself biology appears to mean a greater perceived WMD threat to the national security space. So, you have people getting access to, use lab equipment that contributes to a diminished sense of control over being able to control the supply of equipment, reagents, things along those lines. You also have an increased convergence. So you have not only traditional people doing the life sciences, but you also have regular citizen scientists contributing towards, various kind of life sciences projects, which means you're not necessarily sure how, what the outcome will be of the types of work that these people are doing. And, technology is only getting not only cheaper, but more efficient, more capable. So as technologies become smaller, as technologies become faster, as technologies can do more things, like gene sequencing devices that are, tabletop gene sequencing devices, or potentially even gene synthesis devices that are tabletop. We're talking about the potential to do more things as technology advances. So unfortunately, it seems like do-it-yourself biology from a national security angle is a thing that deserves some concern and increases the potential for WMD threats from that perspective. And that is, this typical perspective that you see in national security circles. So here are a few quotes. You can read through them, but mostly they're about how technology is becoming more accessible, specifically gene editing. People may be able to do all sorts of things with these technologies as they become more available. And, these are communities that have traditionally not necessarily been involved in the life sciences. So there may be security and safety implications that go along with that kind of naivete, that amateur element. So I saw this issue and I was trying to balance it with my perceptions and my experience being involved with the community for 5 years. At this point. It was very frustrating, to be honest, to sit in and listen to people talking about do-it-yourself biology as this threat when I, from my personal observations and interactions, thought there was a more complex picture at play. So with the support of my committee, with the support of the do-it-yourself biology community, I developed a dissertation project looking to understand do-it-yourself biology community labs from a social science aspect, following very much in line with what Dr. Farnsworth recommends in terms of how to proceed with the scientific method. So I developed a one-year study. It looked at 10 community labs across the United States, as well as major spaces that are associated with community labs. So for example, MIT Media Lab is a place that is not necessarily a community lab. It is a major convening space for community labs. In terms of the activities that I engaged in, I did in-depth interviews. I also actively participated in projects, classes, labs throughout that year. And I also did observations. So I gathered field notes and I highlighted observations over the course of a year to develop a very deep understanding of the community labs that I was able to associate with. So this study really focuses on 4 things. How people find out about community labs, what motivates people to participate in community labs, how they are organized, and how people learn and teach in these spaces. So getting to how people find community labs, interestingly, actually not interestingly, because I think it's a pretty obvious phenomenon nowadays. The most prevalent method that people find community labs is through the internet. As Homer Simpson points out, they now have the internet on computers. So that seems to be the most popular method. People are interested in finding lab spaces, and so they look online. People are interested in finding science spaces, so they look online. So that's a typical method. That was the most prevalent method from what I saw in the study. But other methods include interpersonal connections, so friends telling other friends about community labs, professional connections as well. So individuals that are interested in, say, bio art, and they're like instructors of art at various institutions. They hear about community labs as these kinds of innovative spaces for bio artists. And then that's how they then go to these community labs. There's also direct community lab outreach. So community labs often have web pages, they have meetup sites, things like that. And then sometimes it's just a roll of the dice, it's serendipity. So, there were a number of people that I talked with throughout the process that said, hey, I was going to this one place because a friend told me about a poetry slam that was happening in this building. And then I looked around the corner and I found out that there was this lab that was in this building as well. So serendipity also does play a role. It's not exactly empirical, but I think it's just a really interesting little factoid to toss in there. Sometimes it's a little random. So what motivates people to participate in community labs? The main one is a passion for science. These individuals are very passionate about science. They want to learn about science. Maybe they want to engage in science, but there's this fundamental desire to engage in science. And that's what motivates people to not only start going to community labs, but continue participating in them. And then, there are a number of other elements too. These are just some of the top ones. Social interactions. So, community labs, the word community is in there. Community members come together and they talk. So social interaction is considered a very positive motivation for why people go. People also believe in the mission of community labs and democratizing science. So there's an alignment of values with the organization. People also like to engage in community spaces because there's community engagement. You get to engage in community projects and work with community people to build things for the community. And another major one is just this idea that outside of a traditional institution like academia, industry, and government, you have access to an actual BSL-1 lab. So you can actually have hands-on experience rather than just read from a book. You can actually, get your hands a little dirty and do, learn and do some science. So how are community labs organized? This is a blatant steal from Alex Perlman's Twitter. Alex Perlman is an amazing bioethicist who works closely with the DIYBio community. This was from Global Bio Summit, I believe 3.0. It may have been 2.0. Alex can correct me. I'm sure she's involved in Biohacking Village this year. But in this picture, David Kong at MIT Media Lab is presenting how he sees community labs being organized, which is as an armada of pirate ships. So this, these pirates, they loosely associate with each other as a group, but they also kind of go their own path in their own direction, depending on their own particular whims and their own particular desires. The idea here, of course, is also that there is a loose organization, but it's not exactly hierarchical and entrenched in stone. So, community labs are often organized this way, not only from a community lab to community lab basis, like an organizational basis, but also just like within a community lab itself. So what are some of the advantages and disadvantages of having this loose organization style? Well, I see some of the advantages as being autonomy. People can do what they want. Individuals can do what they want. Community labs can engage in projects that they want. Also, many of these community labs are volunteer-based, so they actually have a really incredible ability to operate with exceptionally low budgets. What often comes up in conversations with community lab leads and individuals is they run on shoestring budgets. And finally, with the autonomy element connected with it, community labs can engage in activities that are reflective of the unique local and regional communities that they're a part of. So in the case of Bugs, for example, based in Baltimore, Maryland, they're really interested in barcoding or understanding what lives on a genetic level in the Inner Harbor, which is a body of water that is very significant to the Baltimore ecosystem. So some of the disadvantages, though, is because each group is autonomous and they're so distant, sometimes there are coordination difficulties. You can have issues with coordination across even the United States because there are time zone differences. You also have coordination difficulties within organizations in terms of this, because of the fact that they're volunteer-based. So the thing with volunteer-based is, while you have a lot of people that are willing to do work for no money, when there are situations that take precedence over your hobby of engaging in the community, that means that DIYBio activities won't always be a top priority. So things can fall through the cracks. And just as I mentioned that they're able to operate on shoestring budgets, there are severe resource limitations, and it's not just financial. So a lot of community labs depend very heavily on the lab leadership to do a lot of the heavy lifting. And that's usually 1 to 2 to 3 people that are essentially in charge of making sure that a shoestring budget organization continues onward. And that's a really large burden. There's a significant concern in the community for burnout. People that eventually get burned out because they've taken on too much for a long period of time and there's no respite. So in terms of, finally, how do people learn and teach in these spaces? I kind of divided out the activities as structured versus unstructured. So in terms of how people learn in these spaces, there are the structured styles that actually reflect a lot of traditional academic teaching styles. So there are pure lectures, there are hybrid lecture and lab courses, and there's project participation. Unstructured styles include, just casual conversations, impromptu demonstrations, where people just engage with each other and then just kind of take things as they come, and just explore things with each other in an unstructured fashion. And in terms of the style of teaching in these spaces, once again, it's very reflective of a traditional academic style. And the thing I want to emphasize here is the traditional academic style is not random. A lot of these community labs are run or founded by individuals that have advanced degrees from academia. So when you look at a board or a leadership of a community lab, more often than not, you will see individuals with PhDs in molecular biology, electrical engineering, bioinformatics. These are highly educated individuals, and so it's not surprising that that traditional academic style bleeds into how they then structure the learning and teaching environments in community labs. So, in terms of like groups, they use traditional academic approaches like lecturing, small group demonstration and practice. And then you also have these mentorship one-on-one interactions. So when people are learning like a significant number of lab skills, they're really trying to beef themselves up, learning from a PhD in traditional science, then you get into more of these like hardcore mentorship relationships where they interact one-on-one. The person that is learning shadows their mentor. The person that's learning practices consistently, and the mentor is there often in the beginning to monitor the progress of the individual. So I talked a lot about, how people learn about these spaces, motivation, how people learn in these spaces, and how these places are organized. So is there an implication to these kind of like social elements? And I would argue, yeah, there is. Let's revisit that framework of perceiving WMD threat as it relates to, from the do-it-yourself biology community. So does increased potential capability lead to a greater efficacy for do-it-yourself biology? Can you do more things as capabilities increase? And you know what? On the one hand, yes. So people can construct, self-made, Arduino board guided incubators for plants. So DIY constructs. People can engage in their own sample preparation and analysis. And people can even, in high school, through programs like iGEM, engage in synthetic biology projects in a DIYBio context. However, I would also argue that from some of the observations and some of the data that I acquired, it's not necessarily just because there's an increased potential capability does not necessarily lead to greater efficacy in the DIY bio context. So in the DIY bio context, like I mentioned, there's a lot of secondhand, third-hand equipment, self-made equipment. There's a lot of equipment breakages, which interferes directly with the ability to do science. Also, because DIY bio places are places of learning and of education, there are lots of errors that happen along the way. It's not just professionals doing the sampling and the analysis. It's people that are being taught as well by these professionals, by these, knowledgeable people. And guess what? The students learning, they make lots of mistakes. I can tell you for a fact that I made a ton of mistakes as I was learning how to just even basically pipette things. Also, community labs suffer from environmental contamination issues. We're talking about places where biology is being done in unconventional spaces, whether it's in a warehouse or it's in, a building, or whether it's a place that doesn't have a separate room for your PCR machine that's being kept sterile so that you can get lots of environmental contamination that way. And then, you just have issues with supplies and logistics. So there's this, from my understanding, from the research, there's a very negative conceptualization of the term biohacking. So any place that refers to themselves as a biohacking place, so whether it has biohacking in the name or things like that, companies that produce reagents are very wary about sending reagents to such spaces. So, that could be a limiting factor as well. So does also, in terms of that second risk issue, does greater convergence lead to less certainty of outcomes in the DIY bio context? So on the one hand, yes. People engage in lots of really cool independent projects that you don't necessarily see in academia. So there's this really interesting, it's almost like, it almost looks like a photo that they took on a leaf of a particular logo. I don't quite remember how they did it, but it looks like magic to me, but that's not something that I would expect coming out of an academic lab. Once again, there's that barcoding the Inner Harbor project. The Open Insulin project also is a really interesting example of having citizens get engaged in science. So not only is Open Insulin about finding ways to develop and distribute insulin, given the insulin crisis in the United States and across the globe nowadays, but it also sends a political message of saying that, big pharma is literally holding the lives of diabetics in its hands and trying to find a way to disrupt that. So yeah, there is a certain type of less certainty that comes from an increased convergence. But on the other hand, no. One of the things that I found as I was doing my research was there are definite limiting factors. It's almost like a path dependence model for community labs, where community labs are shaped by the environments that they exist in and the organizational factors that, that they have. So in terms of leadership expertise, the individual that runs the lab, depending on their expertise, may be more inclined or less inclined to do certain projects because they might not necessarily be comfortable with doing things that fall outside of their expertise. There's also the expertise of the community. If you don't have a particular type of expertise that you need to run a particular type of project, you're probably not going to pursue that project. There's also community interest and resources. So is there an interest in the community to actually do a particular type of project or not? And in the case of bugs, for example, like I said, they're really focused on that Inner Harbor, and so they're interested in doing projects that reflect the community, but they might be less interested in doing another type of project that does not reflect the community. And finally, there are a number of community labs that actually have higher education affiliations. and being connected with these higher education affiliation, these higher education affiliates, inherently, because higher education, affiliates tend to be a bit risk averse when it comes to interactions with outside entities. It inherently acts as a limiting factor to make sure that community labs don't just do whatever they want. If they want to participate and get kind of like the validation from higher education, they need to play by certain rules. And finally, does the increased accessibility of technology and knowledge lead to less control in the DIYBio context? So yes, right? People can do independent research. People can learn how to do lab skills and techniques, potentially on their own, at least basic ones like pipetting, particularly through online resources. And there's readily equipment and tools available online for people that want to engage in do-it-yourself biology projects. However, I would also argue that the increased accessibility of technology, so technology and knowledge alone, they don't necessarily lead to less control, because there are other factors to take into account than just these capabilities of like knowledge and capabilities of technology. So once again, community labs are limited by several factors. There needs to be a sufficient amount of scientific expertise in the community to be able to engage as a community lab. So, a lot of this, as I discussed before, is addressed by the fact that a lot of these community labs are founded by people that are experts in science, so PhDs in molecular biology, things along those lines. But there also needs to be a desire or a need for a community lab space. So you're not going to find community lab space popping up literally everywhere. It's a little bit of an easier sell for a community lab space in Silicon Valley, for example, where BioCurious is based, or in Boston, where Boss Lab is based, or Baltimore, where there's a biotech hub in the Rockville area. But you're gonna have a lot of difficulty finding a community lab space in, say, Cairo, Illinois, which is predominantly farmland, and there's not that much of a resource and interest in science. And then there are a couple of other issues, availability of resources, and then there's network and communications issues, which I've previously discussed. So what are we left with? So it's not like I'm saying that there aren't changes that happen with the introduction of do-it-yourself biology to the national security landscape. The implications exist. There are potential risks on biosafety, biosecurity, cybersecurity elements, which I'd be more than happy to talk about during the Q&A. And the thing is, national security experts have a lot of things to deal with very little time. And so having a framework to be able to assess risk is very helpful. These frameworks are like heuristics. They're fast, they work as a mental shortcut, they can be correct, and they're based on the information available. That said, they may lead experts and policymakers astray. The focus may be diverted from more pressing issues, and we may be missing opportunities by, throwing DIYBio out with the bathwater. So don't pull a Ron, don't get frustrated, and throw your computer away just because you don't understand how your computer works. In terms of the opportunities that I think that we're missing by not fully leveraging DIYBio, one of them is grassroots education, community building, and science communication. I think that particularly in an age of misinformation and disinformation, having a community-based science resource could be very helpful in terms of dealing with misinformation and disinformation campaigns. Community labs can function as trusted sources of science information and hopefully communicate proper information that may be helpful in addressing those kind of misinformation and disinformation campaigns. I also see it as a supplemental education resource. So it's not a resource that is taking away from traditional education mechanisms. Rather, it is supplementing the things that people are learning in school. And in particular, the way that I see it being helpful is it offers hands-on experience to individuals. Traditionally, when in academic institutions, they learn a lot of theory. And finally, I see it as an accelerative education resource. So community labs can function very well as places that can expose people that are younger to STEM and critical thinking. Providing individuals with opportunities to see if science is their passion when they're 5 or 6, rather than having to wait, until they're more in their teens. And the other thing that I think that we're missing when we don't highlight and lift up DIYBio is its potential contributions to the bioeconomy. So there was a NASEM 2020 press release that said that the bioeconomy comprises 5% of US GDP, which when you crank the numbers out, comes out to be nearly $1 trillion. It was 950 billion, but I think nearly 1 trillion just sounds that much more impressive. So, given the large amount of money at stake, I think it's interesting that we aren't talking more about leveraging community labs as incubators for future biotech innovation. So we already have some proofs of concepts of this from several community labs, including the OpenTrons project from GenSpace, which is automating lab technologies, as well as over 30 companies that were incubated at Curious, which is based in Sunnyvale, California. So in the context of the talk, what do I think we need to think about? And there are 2 main lanes that I think we need to think about. The first thing is addressing DIYBio community obstacles. So we talked about how there is burnout and heavy leadership reliance issues, so bandwidth issues. DIYBio, particularly being volunteer run, means that individuals have very little bandwidth to work with when they're in this context. So we need to be very cognizant and find out solutions to deal with those bandwidth issues. Also, just the resource issues, like I talked about, financial issues, access to good equipment, access to reagents, things along those lines. And something that I particularly want to emphasize is balancing the economic needs of the community. So understanding that economy is a very important element of making sure that community labs are available and are open and can operate, but also making sure that we don't lose track of its spirit, of its desire to not necessarily be all about capitalism and efficiency, but for it to be a place where people can explore and build communities, because I think there's value in both. And then finally, I think the other thing that we really need to look into is part of the issue with the DIYBio image in the national security arena and other areas is I don't feel like it's had proper exposure. There's been a lot of hearsay and a lot of media articles rather than direct connections between the DIYBio community and other life sciences stakeholders. So building those bridges, building that collaboration, I think is incredibly important with members of industry, governments, governance institutions, and public health. So if you survived this long, I first want to congratulate you. That was a lot. I hope that it was a lot of good food for thought. So I want to first, take a moment to acknowledge the do-it-yourself biology community members and organizations that really helped me out in understanding the community lab scene. I really see this as a community-based project. I really see this as my contribution to DIYBio by engaging in a community-based project with community buy-in. So I really want to make sure that I thank the community labs and DIYBio members at BioCurious, BioDesign Challenge, BioLogic, Biotech Without Borders, Boss Lab, Bugs, Counterculture Labs, GenSpace, Indie Lab, MIT Media Lab, and Open Bio Labs. I really do thank you from the bottom of my heart. And I used that RuPaul animated GIF to show that. And then finally, there's this other side too. Like I said, I'm a NatSec, a national security person as well. And my thinking about the community and my drive to be able to engage with the community to fill what I feel is a very serious gap in the national security perspective would not have been possible without all of the people that are here as well on the security and safety side. So I really want to thank Nina, Bo, Nalja, Sydney, Josh, and everyone at Biohacking Village. I really do appreciate you giving me this platform to, have these conversations, build connections, and see what comes out of it. I also really wanted to thank Gregory Copeland, Sonia Ben-Wagram Gormley, Trevor Thrall at George Mason University, Natasha Bajema at Nuclear Spin Cycle, Todd Quicken at NCSU, Seth Karras, Diane Diulis, Gerald Epstein at the Center for the Study of Weapons of Mass Destruction, Gigi Quick-Rumble at Johns Hopkins Center for Health Security, as well as Matt Watson and Crystal Watson and Michael Montague. And then a special a little shout out to my Friday LB night crew, Nicholas Evans, Emily Kelly, Mary Lancaster, Amanda Moody, Saskia Popescu, and Emily Ricotta. And with that, I'm sure that everybody has questions, comments. If you want to also even engage in a bit of old-fashioned trolling, I'm available for Q&A. You have my email right there, and you also have my Twitter. And with that, we are done. And I want to thank everyone for hanging in there with me.